In this lesson, we're going to explore block boundaries and transitions. In several of our other lessons where we utilize the butterfly topology, such as Intro to Projection, we demonstrate gluing adjacent faces together using the block boundary command. This allows the boundaries' shared nodes to participate in the smoothing along the interface. In this lesson, we're going to explore all 5 ways that we use the block boundary interface command.
So this might be the simplest example of it. We start out with the mesh looking like this, with this edge and this edge projected to a surface cylinder. But we want this edge to meet this edge perfectly. So by attaching with the block boundary command, we can glue them together like this. So I'm going to create a shell mesh where k is a constant. And I'll delete one block, and then I'll move this node, move in the screen plane. I'll make this the master, and I'll make this the slave. So this is going to move to the master. So there's the command, and when I tell it to redraw, it remakes the mesh. So that's a way to make sure that there's no gap between 2 faces that should be together, and they're exact. If we go into the merge phase, and I tell it to merge common nodes, and I'll use a tolerance that's quite small, it still merges them.
We're going to build a quick spherical mesh for the purposes of demonstrating the block boundary commands. But please do not ever build a sphere this way when you mesh. It's a poor quality mesh. You will need to build a quality mesh as illustrated in the lesson named Projecting a Sphere.
So I'll go to the Parts menu, click on the Block command, 1 to 11 in all 3 directions. Block boundary interfaces are in 2 steps. First, you create the master side. Then you create the slave side and attach it to the master. I'm going to start, first of all, by projecting this to a sphere, all 6 faces. So I create the surface. I go to Surface, SD, surface number 1, a sphere. Now I've set it up so it's symmetric around the origin. So I'll use 0, 0, 0 as the center of my sphere, and I'll use a radius of 1. You can barely see the sphere inside. It's just barely poking out at the tangent points. If you rotate this, you can see some notion of that sphere. So I'm going to select all 6 faces. You select the solid first by doing a click and drag on the index bar in all 3 directions. That gets me the solid. Then I go back and click on the end nodes of the faces of that solid that I want to be selecting. In this case, I want all 6 of them. So I click and get the first face, click to get the opposite one, click, 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 click. So now I've selected all 6 faces. And then I need to select the geometry. Of course, it's inside, but that's not a problem. If we go to the Pick panel, Surface, do a little box like that, it'll select that sphere. So I've selected the mesh, I've selected the geometry. The next step is Project. And now those nodes are stuck on that surface. I can change their initial position, but they'll always be on the sphere. Let me show you an example of that. I'm going to take this vertex right here and move it over someplace. I'll use the move points in the screen plane, and I'll move this over to that point right there. It's still on the sphere. I'll undo that now because my goal here is to show you the block boundary interface. And I'm going to click on the second node in the I direction, on the I index bar. That's going to be the face that I'll turn into the master block boundary interface number 1. To do that, I go to the main menu and then the interface and click on BB. And then I hit F1 to enter the selection into the BB dialog box. And I give it a number. That number is important. From now on, any other reference to block boundary interface number 1 will be a slave to this block boundary interface. So now I'll hit F2 to get rid of the highlight. And we can look at the block boundary interface. If we go to the environment window, display list, BB, show all. There's the block boundary interface number 1. If we go to labels and label the BBs, you'll see that it's number 1.
Now we are going to create a second part to the right of our sphere with the same number of elements as our first part. It's critical when using the block boundary interface that you make sure that the number of nodes in the master and slave match. We will use 1 through 11 in all 3 directions, just as we did in the first block part. But this time, we're going to move the x-coordinate over to the right so that the 2 parts will be close but not touching.
So here's my second part, and I'll once again have it display all of the block boundaries. And you'll see this block boundary is close to this face right here. Now, the rule of moving things around to get them close applies to block boundary interfaces as well. And the reason is that there are actually 8 different ways that this face of the mesh can be mapped to this block boundary interface. So getting it close tells TrueGrid which of those 8 ways to do it. And you don't have to get that close. It's remarkably resilient. Now, all we need to do is to assign this yellow highlighted face to be block boundary interface number 1. So once again, we go to the interface menu and select the BB command, hit F1, and call it block boundary interface number 1. And then when we redraw the picture, you see that that face has now taken on the node for node tie to the block boundary interface on the master side. And it is stuck there. You can't project it away. You can't move it away. Well, almost. There are some strange things you can do to change the initial position of the slave side so that TrueGrid chooses the wrong way to map. And I'll show you what I mean by that. I'm going to move this vertex over to here. Here you see the PV command. It changed its initial position, but it still managed to do the right combination. If we go back to the history table, and we turn off the slave block boundary for just a moment to see how this face is distorted, and yet it chose the right interface mapping. Well, I'll turn that back on. Now what I'll do is also change this node. So I'll move it over to here. Now there was enough of a perturbation in the initial shape of the slave side to cause TrueGrid to choose the wrong mapping. And you can see what a wrong mapping will do. And all you have to do is to make sure that the slave side is reasonably close to the master, and it'll then glue it together perfectly. And you can easily fix this and take this vertex and move it over here. All it took to fix it. I changed the initial condition for the slave side, and it automatically chose the appropriate mapping from the slave to the master. We can apply a transformation on the slave side. So I'm going to undo the block boundary command so that I can show you another way to use it. I'm going to undo that as well. Let's undo some more. There we go. Now we're back to a decent shape. I'm going to now attach this face to this block boundary with a normal offset. So here's another example of applying transformations. I'll use the BB command, and I'm going to apply the minimum I face. But this time, I hit F1, I am going to apply a transformation, but in this case, it's an unusual one. It's a normal offset. So I'm going to have the slave side be offset from the master side. I want to make it obvious, so I'll make it 0.05. I forgot to put in the block boundary interface number. Okay. So I've got the region. It's block boundary interface number 1. It's a transformation known as a normal offset of a 0.05. So now it's glued, but there's a normal gap between the master and the slave. Now, there are some codes you might be using where you need to have a gap between contact surfaces. And this is a good way to make that gap. So the contact surface is not requiring some sort of fix in the initial time step because they're already separated properly. Now I can also do a periodic property. I can force this face to be the same as this face, but translate it. I'm going to place this maximum I face and glue it to the same block boundary interface with a transformation. This is used for developing periodic models, a shape that can be repeated many times and they fit together like a puzzle. But it's also going to be glued to the same master, number one, but with a translation. So I choose apply a transformation. In this case, it's going to be translation in the x direction, a -2. The distance from here to here is a -2 in the x direction. And so now this is also glued to the master by a transformation. Now I'm going to show you another feature of the block boundary interface. The master side doesn't have to change in this example, but the slave side does. I'm going to change this interface. So I'll go to history, turn off this first block boundary interface command because I want it to use transitions. Now transitions allows you to have two parts with a different elements and they're glued together perfectly. But to do that, I'm going to change the number of elements in this second part. I want to have twice as many elements here and 3 times as many elements here. So the first thing I'll do is use the msec command, and in the J direction, I'm going to add 10 more elements. And in the K direction, I'm going to add 20 more elements. I'm being very careful here in how I do this because the ratio has to always be maintained. It's either a 1:2 or a 1:3 ratio. Now I've got a 1:3 here and a 1:2 here. So now I use the TRBB. It stands for Transition Block Boundaries. So I hit F1 to select, oops, I made a mistake. Notice that I can make a change, come back to this dialog box and hit F1 again, and it makes the corrections. It's going to be block boundary interface number 1. Now I want to point out that the TRBB command only is on the slave side. It's never on the master side. I don't think we need to apply any transformations here. So we're good to go. Now, when you do this, it may appear as though nothing changed. It's just like any other block boundary interface. You will not see the differences until you go into the merge phase. I think before we go to the merge phase, I should add more elements in the I direction. Otherwise, we'll have high aspect ratios. And I think I'll put in 20 more, no, 15 more, kind of an average between the other two. Okay. Now I'm going to go into the merge phase. You don't see the transitions now, but you will once we go into the merge phase. So I'll type in merge. And now we have our two parts. And now let's zoom in here to see what we've got. These are all well-shaped hexahedral elements that interface these two parts. This is what we call the transition region. Now to see it more clearly, I'm going to remove part 1, RP1, and I'll remove the block boundary interfaces. So we're looking at the inside of that interface, and it looks no different than the block boundary that was formed on the master side, which is what we need. But then we have these transitions. Let's do it in color. Maybe it'll be easier to see. It's quite complicated, but they all are hexahedral elements. I can prove that to you by showing you another feature in TrueGrid for creating sets. Sets have many uses in TrueGrid and for analysis. You can use them for properties and for sets that get used in a code that requires sets. To create a set, there are a variety of ways of doing them. The one that's most interesting but turns out to be not that practical is using the mouse to select. So I'm going to use the mouse to select a set of elements, brick elements, and I want to use the option where at least 3 nodes of a brick element have to be selected with the lasso before they are selected for the set. So I'll try to do this reasonably, but I have to have a very steady hand. Okay, so these are the elements that's selected by that motion. And I'm going to turn that into an element set. I'll save it as E1. And then I'm going to change the material number for all of those elements that are in E1. I'm going to call them material number 1. That's from element set E1. And their colors now changed, and I can remove these elements, remove material 2. So now we can look on the inside of the transition. This is probably one of the more important features in TrueGrid.
With transitions, you may not initially think that there is much value because the step down in element count is relatively minor with only one transition. But it's common that customers will want to build an all hex mesh, but there is a critical region of the mesh that needs to be high density. So we layer the transitions. If we layer 4 1 to 3 transitions, for example, we go from 1 to 3 to 9 to 27 to 91. On a large mesh, this is a significant savings in time.
You only have 2 choices of transitions, either 2 to 4 or 1 to 3. But then you can combine them in all sorts of ways. Keep in mind that the transitions are always on the slave side. So when you look at this part right here, this is the slave side, this is the master side. Now there are going to be times when you want to build a transition around a fine mesh. So you've got a very fine mesh in the middle, and you want to radiate out and put these transitions. You want to make sure that you put the transitions on the outside. In other words, when you have your fine mesh in the middle, all of your master sides are on that part. And then you build a second set of parts that go around it, and they will be the transition interface parts. There's a discussion of that in the manual. But just be aware that order can be very important when you do this. Plan this out. This is not something you do on the fly.